Hello friends, today we discuss about some example. Example number 5. Right. Now, see here. A small bulb is placed at the bottom of a tank containing water to a depth of 80 centimeter. What is the area of surface of water through which light from the bulb can emerge out? Refractive index of water is 1.33, and here we have to consider the bulb to be a point source, right? So here the data is a small bulb is placed at the bottom of tank and the depth is 80 centimeter, right? So here we assume this is our tank. Like this. Here the depth of the tank is 80 centimeter. So here H is equals to 80 centimeter. Here if we have to convert to the SI, then H is equals to 80 centimeter. If we have to convert centimeter to meter, so here we have to divide by 100. So we can say that H is equals to 80 upon 100, so 0.8 meter. So you can say 80 centimeter or 0.8 meter, right? Now small bulb is placed, so you have to consider here a small bulb, but here this small bulb is a source of light, so here we denoted this point by S, right? So the question is, what is the area of surface of water through which light from the bulb can emerge out? So here we have to find out the area, right? So we have to find out area A is equals to how much? Refractive index of water, that is N, 1.33. You have to remember this refractive index of water 1.33. Refractive index of air, which is 1. Refractive index of glass 1.5. So these three values you have to remember. Once again I repeat, refractive index of water 1.33, refractive index of air 1, for glass 1.5. Okay. Now here there is a source at a depth of 80 centimeter. So here we denoted H is equals to 80 centimeter or 0.8 meter. So here this is the source. Now this source emits a light, right? But here this is a point source, so the light emerging out in a circular path, right? You can understand this through example કે તમે જ્યારે ટોર્ચ લો, એ ટોર્ચને તમે જ્યારે વોલ સાઈડ રાખો ત્યારે તમે જોવો છો લાઇટ સર્ક્યુલર પાર્ટ ક્રિએટ કરે છે, right? So here this source which emits light in a circular path, so here this is a incident ray like this, and this is also incident ray like this. This creates a circular path like this, right? So here this is the radius of circle, right? Now friends, this is the incident angle, this is the normal. So here like this, So this is the incident angle normal. So this is angle of incident. But here the ray incident at a surface at critical angle, right? So the ray refracted like this, right? Here this is also critical angle, so the refracted ray like this. Now here you can see that this is the Z. So here if this angle is critical angle IC, then this is also IC, right? So friends, we have to find out the area, and we know this is circular, so that the area of a circle is pi r square. We know that pi is equals to 3.14, but we don't know the value of r, right? So first of all we have to find out the r. So here see this geometry. Here this is IC, which is critical angle. Here R, this is the opposite side, and this is height, which is the adjacent side of IC. We know the relation between opposite and adjacent side, tan theta, right? So from the figure we can write that. From the figure, tan theta, theta is equals to IC, is equals to opposite side by adjacent side, which is H. So we can write that R is equals to H tan IC. Here we know the value of H, 0.8 meter, right? But we don't know the value of critical angle. So here this is our equation number 1. So to find out area we have to find out R, and to find out R we have to find out the value of critical angle. So the question is how we can find out the critical angle. So friends, we already know the formula, we studied this already. We know that the formula of critical angle by Snell's law, n is equals to 1 upon sine IC or 1 upon sine C, right? So C or IC, this is critical angle. So from the formula we can say that here n is equals to 1 upon sine C or IC. So we can formulate sine C. So sine IC is equals to 1 upon n. We know the value of n, 1.33, which is refractive index of water, right? So sine IC is equals to 1 upon 1.33. So with the help of calculator we can say that sine IC is equals to 1 upon 1.33, which is 0.7518, right? Now we have to find out the value of IC, right? So we can say that IC is equals to sine inverse 0.7518, right? So here we have to use the natural sign to find out sine inverse 0.7518. So IC is equals to, how can we find out sine inverse 0.7518? So see here friends, we have to find out the value of sine inverse 0.7518, right? Now see friends, this is our natural sign, right? We have to find out the value of 0.7518, right? So here we show the first column with the value of 0.7518. So here see 0.02, here this is 0.50, right? See here 0.5592. So here we check in the next column. Here see here 0.7431, here 0.7547. we have to find out 0.7518. so here we have to check the line of 48 degree, right? So our degree is 48. Now here in row 0.7431, 7474, yes, see here 7501, here 7513, check it, yes, here this is the value of 0.7513. we have to find out 0.7518, right? So here we have to add 5, right? So here if we add 4, so here the answer is 48 degree, and here this is 0.7 degree, right? Here, or we can say that 42 minute, right? So if we add this like so 48 degree, right, and 42 minute 7513, if we have to add 4 because we have to find out the value of 0.7518. so if we add 4 then 0.7517, right, which is around 0.7518. so we have to add 2 minutes, so 42 plus 2, so 44 minutes, right? So our answer is 48 degree, right, and 44 minute. So 48 degree and 44 minute, right? So here this is our value of critical angle, right? Now we have to find out R. So R is equals to H10IC, right? So from the equation 1, so from equation 1, R is equals to H10IC. So R is equals to value of H. We know the value of H, 0.8 meter, right? 0.8. And 10 IC, IC is 48 degree and 44 minute, right? So 48 degree and 44 minute. Now we have to find out the value of 48 degree 44 minute in natural tangent. So R is equals to 0.8 into, now natural tangent, see here 48 degree and 44 minute, here see 48. So here we have to starting with 1 point, so at 42 we get 1383, right? So we can say that 1.1383, right? So here we write that 1.1383, but this is the value of 42. We have to find out for 44. So here we have to add the main difference. So here add 2, main difference is 13. So here we have to add 30, right? Okay. Now as we add we get 1.1396, right? So here 1.1396. As we multiply this, we can get R is equals to 0.9116 meter, right? So here R is equals to 0.9116 meter. We have to find out the area. So we know the area of circumference. Area A is equals to pi r square. So we use the formula area is equals to A is equals to pi r square, right? So here value of pi 3.14, r square value of r 0.9116 whole square. So we get area A is equals to around 2.6 meter square. So here this is the area, right? Here for future purpose we can also write that light coming out of circular path, right? So in future this is useful for us, right? You can understand this question. Okay, now we discuss about our next example. Now see our next example, example number 31. Light incident normally on a plane mirror attached to a galvanometer coil retraces backwards as shown in figure, right? You can see in this figure this mirror M is retraced backward. A current in the coil produced deflection of 3.5 degree of the mirror. So here the deflection produced by the current in coil is 3.5 degree of the mirror. What is the displacement of the reflected spot of light on a screen placed 1.5 meter away, right? So here see this figure, friends. This is the mirror, this is the deflection, right? This, so this is the deflection, this is the screen, the distance between screen and mirror is 1.5 meter, right? So this point is the deflection, right? So here, friends, a current in a coil produces a deflection of 3.5 degree, right? We rotate the mirror, right? So you have to remember this line. When mirror is rotated by an angle theta, right, here like this theta, so the position is changed M from here, next position is M dash, right? This is the angle theta. Then reflected ray will be rotated by 2 theta, right? So the reflected point will be obtained at here, right? I repeat this sentence. When mirror is rotated by theta, its position changes from M to this point M dash then the refracted ray will be rotated by an angle 2 theta. So here this is the angle which is 2 theta. Hence reflected point will be obtained at some point here, right here, this point. So here I redraw the figure like this. See, this is the initial condition when the mirror M, this is the screen, distance between mirror and screen is 1.5 meter. In the primary condition, like this is our point. Now we rotate the mirror from M to M dash here by angle theta. Then the refracted ray will be rotated by 2 theta. So here the deflection from this point to this point we can write like this point Q. So this is the deflection, right? This angle is 2 theta. We have to find out the displacement. So here something, the displacement is small d. Here we assume distance between screen and mirror is capital D, right? So there capital D 1.5 meter, right? So we can write this sentence. When, here you have to remember this sentence, when mirror is rotated by theta and its position changes from M to M dash, then reflected ray will be rotated by an angle 2 theta. Hence reflected point will be obtained at point Q. In initial condition the point is R, so we can say that at point Q from R on screen, right? So here suppose I denoted this point by an O, so we can say that angle ROQ is 2 theta. So angle ROQ is equals to 2 theta. So 2 into, here we know the angle theta, here a current in coil produce a deflection of 3.5 degree. So here angle theta is 3.5 degree. So we get 7 degree, right? Now here we have to find out the displacement, right? So displacement is Q from R, which is denoted by D. So we have to find out small d here. Capital D is known. Here angle 2 theta, we know the value of 2 theta is 7 degree. So here this is the opposite side and this is adjacent side. So once again we use tan. So we know the formula, tan theta. So from the figure, tan theta, instead of theta we have to write tan 2 theta is equals to QR upon RO, or we can say that QR is small d and RO is capital D, right? We have to find out small d. So we can say that small d is equals to capital D into tan 2 theta. So small d is equals to capital D, which is 1.5, into tan, value of 2 theta, 7 degree, right? So small d is equals to 1.5, tan 7 degree. We know we have to find out from the natural. So we have to find out tan 7 degree in natural tangent. So in natural tangent, tan 7 degree is equals to 0.1228. So we get small d is equals to 0.1842 meter. Right? Okay friends, you understand this? Okay. If you want to convert this into centimeter, then we get 18.42 centimeter. Okay, you understand this? Thank you.